All right, NASA is sharing more photos captured by the most powerful orbital observatory ever launched into space.
So for more on this exciting news, we're joined now by Jesse Rogerson, Assistant Professor of Astronomy at York University. Jesse, great to have you with us on the show again. So some new images have been released from this $10 billion telescope, the James Webb Telescope, and it captured some pretty beautiful images, blue and orange, of the death of a star.
That's right. That image is of a planetary nebula. A planetary nebula is what happens when a star like our star, the sun, reaches the end of its life. And when that happens, it sheds all of its outer layers in these big sort of shows of circles and bubbles almost. And see, there's a great image of it there showing the outer layers of the star flying away from the core of the star being left behind. So, fast forward 5 billion years from now, and that's what our sun is going to look like, roughly speaking. So with an image like this from JWST, we can get a sense of how a star dies, how it reaches the end of its life, and how it gets its material back out into space.
Hey, Jesse, don't laugh, but could this possibly confirm or deny if we're not alone, if there, additional life out there either now or millions of years ago?
So that is one of the most fundamental questions of astronomy, right? How do we fit into the universe? Are there other things like us in the universe? And one of the data that was released today, is a spectrum of an exoplanet's atmosphere. So the exoplanet, it's a planet that orbits another star way out there, about 1,000 light years away. And the light from the star has gone through the atmosphere of that exoplanet, and then we analyze that starlight with JWST. And what we found in this spectrum is there is clear evidence of water vapor in that atmosphere.
Wow.
Now, don't get ahead of yourself. This is a gas giant planet. It is a gas giant, and it's really close to its star, which means that there's no life there. There's water vapor there for sure, but there's no life there. But what this is for us is a proof of concept. It means we can study the atmospheres of exoplanets now, and it was done by a Canadian instrument built by the Canadian Space Agency. And I think that over the next 6 months or so, you're going to see a whole bunch of spectra of exoplanets, potentially showing water, potentially showing oxygen, potentially showing methane. I mean, I can't say those are big pieces of evidence, but it would be really exciting to get some answers to those questions.
Yeah, absolutely. Jesse, I know you follow all of this so closely. We also saw dancing galaxies, but for the layperson who sees these images and just look at it and they don't have a true appreciation like you do, and they say, oh, this is pretty, some stars, some dots, some colors, but how do they interpret that? What are they supposed to make from looking at those images, and what's the insight you can say to people like, hey, this is special because this will help us learn more about this? And could it perhaps give us a clue about when, I know this might be a morbid question, but when the Earth might disappear, other planets might come to their end?
Yeah, I think the ultimate goal of astronomy, the ultimate goal of just looking out into nature, whether it's up under a rock down to the bottom of the ocean, the ultimate goal is to try and figure out how we fit into nature. It's like the ultimate human condition, right? How do we fit in? And astronomy's big contribution to that is trying to show, are we the only Earth? Are we the only life form? Is the sun common? Is our galaxy common? And to do that, you got to answer questions. You got to go all the way back to the beginning of the universe. You got to say, when did the first stars form? When did the first galaxies form? But you also got to look at the really nearby stuff, like the other planets out there, and you got to see what are those planets made of? Are they Earth-like? Do they have atmospheres? What's in those atmospheres? So when I show images like these to people, these are the things that I talk about. Like, how do we know how to move forward as humanity without having a sense of place in the universe that we live in? That's fundamental to the way we want to live. So it's very philosophical, but it's important. These are important questions for humans.
Okay, Jess, we have about 45 seconds left, and I have to ask this. You've heard the saying, it's a small world after all. With these new images, how small are we actually?
Oh my gosh. Physically speaking, we are so tiny. We are insignificantly in size. But I really feel that when you see images like this, it makes me feel that we are incredibly significant.
Wow.
Because out of that entire massive cosmos, 13 billion light years away, billions of stars, billions of galaxies, we've been able to create this instrument, the James Webb Space Telescope, affix it with these incredible instruments like NEARIST by the Canadian Space Agency, and look out into our universe and actually understand what we're looking at. And that's a really big accomplishment. I think we should pat ourselves on the back for it.
Yep.
And it makes me feel really connected to that really massive universe. So physically small, but metaphysically big.
And that's what $10 billion will get you.
Exactly. Jesse, I love the way you just framed that and put that forward. It was so poetic and beautiful, and you've given us so much to think about. You know, we'll be thinking about more when we look at these images. So Jesse Rogerson, Assistant Professor of Astronomy at York University. I don't know, should we do the signal? Maybe we did it at breakfast.
Oh, yeah,
yes,
there we go. Live long and prosper.
or to infinity
live long and prosper.
Or to infinity and beyond. It could be either way. Thank you so much, Jesse. Take care. Appreciate your time.
Thank you. Have a good one.
Thank you.